Hi there, this is Kamesh. This video is about our project explanation. Our project title is Head Motion Controlled Wheelchair for Disabled and Quadriplegics. Our project mentor is Dr. Velayudham sir, and our project teammates are Durai Saranakumar, Gautam and Karthikeyan. Our project aims to serve the quadriplegic person to have the independent mobility on their own without any care assistance or the assistive caretaker. So, the quadriplegia is a condition that leads to a person's paralysis of all four limbs and the torso. In this case, the person can't able to have the independent mobility on their own. So, our project will have the solution to solve the problem to have a independent mobility. They can go anywhere with just a head motion. So our project consists of two main components. One is the transmitting section and another one is the receiving section. So in this transmitting section part, we will have a look at the first part, that is accelerometer sensor. It is a MPU 6050 accelerometer which detect the angle in the three axes. That means X, Y, Z. So within a second, it will detect the value up to 100 values. So whenever the accelerometer will get the power supply, it will be start detecting the angles. It will be attached to the headband which will be weared by the user's head or the quadriplegic person. So the person will be wearing this headband with the accelerometer. So whenever the person tilt their head or make a head gesture like forward or turn right or turn left or turn tilt backward their head, the accelerometer will detect the some values. Like whenever the angle changes in the XYZ direction angles, it will have a certain labeled values. So whenever the person's head is tilted forward, the certain angles will be changed in the XYZ direction. So we have assigned the values like whenever the user's head tilt forward, it will be labeled as 2. Whenever the user's head turned right, the data will be valued as 3, and whenever the user's head is turned left, the data will be valued as 4, and whenever the user head tilt backward, the data will be valued as 1. So the detected data will be transmitted to the Node MCU microcontroller unit. It is a Node MCU ESP8266. So it will control the entire transmitting section part. So also it will send the gather data from the accelerometer to the receiving section, also to the Blink IoT application. It is a software application through the Wi-Fi. So the PCB board and the microcontroller, also the accelerometer will get power supply through the 12 volt lithium ion battery, will be connected to the PCB board with the step down voltage regulator. It is a 12 volt. So the step down voltage regulator will be step down to the 5 volt. The 5 volt will be transmitted to the Node MCU, also to the accelerometer. Here we can see the prototype model. It is a wheelchair prototype model and the receiving section of the project. So the receiving section of the project will be connected to the wheelchair through the connector wires. It will be connected from the L29N motor driver to the 30 RPM motors. So it will be connected to the wheels. This is the receiving section unit. So in this PCB board, it is the main Node MCU microcontroller 8266. The same controller we have used in the transmitting section. So the data from the accelerometer through the user's head motion will be transmitted from the Node MCU from the transmitting section to the receiving section Node MCU through Wi-Fi. So whenever the receiving section get the data, the data will be transmitted to the L298N motor driver, so which is functioning the motor driver's rotation. So whenever the L298N motor driver get the value, for example, if the person tilting their head forward, it will be labeled as 2. So the accelerometer will be send the data to the transmitting section Node MCU, and the transmitting section Node MCU will send the data to the receiving section Node MCU through Wi-Fi. The data 2 will be sent to the L298N motor driver, and it will perform the function of rotation of the wheel. It will be, we have designed as a rotation of only forward and backward. So the right side wheel and the left side wheel accordingly. So the value data 2 will be functioning as the rotation of both sides, like left side and right side will be rotation of forward motion. So whenever the data will be 2, the wheelchair will be moved forward, and then whenever the data will be valued as 3, like the user head is turned right, the data will be valued as 3. So in that type of data, the L298N motor driver will rotate the right side wheel backward and then left side wheel forward. So while rotating the wheel simultaneously like that, the wheelchair will turn right with that motion. So whenever the data is 4, that means a turn left action, the left side wheels will be rotate backward and the right side wheel will be rotating forward. So the wheelchair will rotate or turn left. So the data value 1 will be considered as stop. So whenever the wheelchair is moving forward, whenever the user's head tilt backward, the 1 will be generated, though the 1 data will stop the wheelchair within a second. So, and another important novelty of our project is a fault detection mechanism, where it will be implemented by the accelerometer. It is the same accelerometer used in the transmitting section. In this accelerometer, we will be detecting the values within a second up to 100 values. Though whenever the wheelchair make an angle of fall detection, like if the wheelchair is fall, if the wheelchair is make a fall, the data will be considered as the fall detection. The data will be changed to the angle, and then the fault detection mechanism will be triggered to the node MC microcontroller. The node MC microcontroller will get the GPS location of the wheelchair, location like latitude and longitude of the data. The data will be sent to the Blink application of the IoT, and the caretaker will have an alert notification with the latitude and longitude coordinates of the wheelchair. And then the power supply will be get by the lithium 12-volt lithium ion battery, and also with the step-down voltage regulator. So this is the Blink IoT application. So whenever the device is off, we can see the offline signal will be visible here. So I'm going to connect the power supply to the transmitting section. So I just connected the power supply to the transmitting section, and the accelerometer will also receive a light signal like it is connected to the power. So once the transmitting section is connected, will get power supply, and it will be connected to the internet through the hotspot through my mobile. So you can see here it is in the green signal. It means that is in online. We will also have a notification here like it becomes online. It is 5:30 PM now, so it is online now. So here we can able to send the location data here, and we can also share the data on, and also start and stop of the wheelchair on. So if I off the data for both of them, it will not send the data from the accelerometer to the wheelchair. So consider him as a quadriplegic person. He is going to have a head motion. He is wearing a headband with an accelerometer connected to it. So whenever he had a head tilt motion or head gesture, the values will be changed accordingly in the Blink application. He is going to perform a head tilt motion forward. So now we can see that whenever he have a head forward direction, it will be changed as 2. He is going to turn right now. So he is turning right. It is considered as the value as 3, and he is going to turn left now, and it is recording as a 4. Now he is going to tilt his head forward, and the wheelchair is going to move forward. The wheelchair is moving forward, and whenever he turns right, it is going to turn right. Now the wheelchair is turning right according to the data received from the accelerometer. Now he is going to turn left. Then the wheelchair is going to turn left according to the data. The data will be 4.
and the right side data will be 3. Now he is going to turn right, so the wheelchair is going to right.
In the receiving section of the project, here you can see the another accelerometer, so it is going to perform a fall detection. So whenever the wheelchair have a fall, so the angle will be detected in the wheelchair. So the blink note application will have a notification that wheelchair fall down. So the caretaker will have a instant alert notification, and he also have a notification history. In this notification history, he can see that how many times the wheelchair has fall down. So now the time is 7:06. So at the 7:06, the wheelchair has faced a fall, and the fall detection system mechanism have been triggered by the receiving section.